So 1.1, intro to functions. We're going to start first just making sure we know how to identify a function. So a function is a relation in which each input is assigned to exactly one output. And when we're saying input and output, we're talking about the input values are going to be your x's and the output values are your y variables. So what this means is that each x can have one and only y. One and only one y. If you have an x value that has more than one y, it is not a function. When we're looking at graphs, we're going to use this vertical line test. And the vertical line test states that a relation is a function if and only if a vertical line does not pass through more than 1 point on the graph of the relation. So what you're looking for if you're looking at a graph is if I draw a vertical line, does it hit that graph in more than one spot? Because if it does, then it's not a function. If you can draw a vertical line and it only touches that graph in one place, then it is a function, okay? Which is, example number 1 is a graph. We've got this parabola that is opening up. So if we think about that vertical line test, no matter where I draw a vertical line, it is only going to pass through that parabola at one spot. Each x only has one y. So this is an example of a function. Then number 2, hopefully that one's pretty easy to tell. If I draw a vertical line through x equals 2, well, you'll notice I've hit the graph in 2 different places. So this input value of 2 has 2 different output values, 2, 2, and 2, negative 2. So that 1x has two y's. So this is not a function. Number 3, I gave you a set of ordered pairs. So in your homework, you might see ordered pairs or tables or like mapping diagrams. So what you're looking for, again, is that each x has only one y. So if I look at these ordered pairs, hopefully what you recognize is that this x value of negative 3 has 2 different output values. So because this x value of negative 3 has 2 different y's, this is not a function. Again, each x can only have one y. So that means if the x repeats, it's got more than one y. So that's not a function. All right, and then our last example is back to a graph, number 4. Now this is a rational function. So remembering that we've got this vertical asymptote right here, which means this graph's just going to get closer and closer to the vertical line, and this graph is just going to get closer and closer to that x equals 3, but it's never going to cross. So if we go back to that idea of the vertical line test, no matter where I draw that vertical line, it's only going to pass through that graph in one spot. Okay, so this is a function. All right, so that's the easy part. Identifying if it's a function or is it not. Now, domain and range sometimes gets a little trickier. Yes?
I need Paul for checkout, please.
He's not in this class.
No?
I think it's because you looked at 7.
Sorry.
Yep, it's okay.
Thank you.
Yep. Told you that will happen like every day. The domain. So, the domain of a relation is the set of inputs. So these are all your input values. And remember that input means the x values. So when we're talking about our domain, if we're talking about our x's, remember our x is our horizontal axis. So with our domain, we're looking left and right. What is the minimum, maximum x value, okay? Those are your inputs. Then your range is going to be the set of all outputs. And again, your outputs are your y values. And so our y values is that vertical axis. So we're looking at what are the possible values along that y axis, that vertical axis. Now, when we're representing the domain and range, we have to be able to represent it in both inequality notation and interval notation. So inequality notation is when you're using your inequality signs, greater than, less than, greater than or equal to. So if your value is a part of the range or the domain or the range, so if it is included, then we would want to use our inequality signs that show that it's included. So we'd want to use greater than or equal to or less than or equal to. If it's excluded, meaning that value isn't actually part of the domain and range because there's an open circle or something like that, then we would just use the greater than or the less than signs. So when you're using inequality notation, greater than or equal to, less than or equal to, if that value is included in the interval, so in the domain and range, or just greater than or less than if it's not. Now, with your interval notation, that's where you guys use the brackets. Remember the brackets and the parentheses? So if the value is included, that's when you use the square brackets. And if the value is not included, that's when you use the parentheses. And remember with this bracket notation, I don't know if you want to make yourself like a little note or something, but that's when you would literally put the minimum value, comma, maximum value, and then again, you either have the brackets or the parentheses. So that interval notation has to be minimum value, comma, maximum value. Just as a little, but we'll practice that when we do our examples. And really, anytime you do domain and range, you always want to make sure it's represented least to greatest, so minimum to maximum, okay? And when we are dealing with infinity, infinity is always excluded. So infinity always gets the parentheses, all right? If you're using infinity, it does not get a square bracket. It always gets the little parenthesis. Okay, so now let's practice them. So we got 3 examples, and they're all a little unique in their own way. This first one, number 4, we've got this little cubic function that has these endpoints. So it's continuous along these endpoints, but it's not continuous forever, like in number 6 where you see the arrows. So we have this continuous graph between these endpoints. So first, let's do the domain. So the domain, we're looking at those x values. So we're looking horizontally. What's the minimum? What's the maximum? So the minimum is going to be the furthest left. The maximum is going to be the furthest right. So the furthest left point is this endpoint right here. And then the furthest right point is this endpoint right here. And all these values on the x-axis between -3 and +4 exist because this graph is continuous. So when we write this using the inequality notation, our x values are in between the minimum and the maximum. So when we write it, let's start with the minimum x value, which is, I think I said 3, but -4, right? -1, 2, 3, yeah, -4. So we've got -4, and that's going to be less than or equal to our x, which is less than or equal to the maximum value, which is the 3. So this x value is in between -4 and 3, because -3 is the minimum, or -4 is the minimum, I'm sorry, and then +3 is the maximum. So x is in between. Am I wrong? 1, 2, 3. That's right. 1, 2, 3. Yeah. So let's stay with domain and just jump down to the interval notation. So again, remember with that interval notation, you just have the minimum value, comma, the maximum value. and then either brackets or parentheses if it's included or not included. But since it was less than or equal to, and less than or equal to, and we have these closed circles, that means it's included. So we're using those brackets for the minimum value, maximum value, bracket. So square brackets because it's included. All right, now let's look at our range, and we'll do our inequality notation first, and then we'll do the interval. So with range, remember you're looking along that vertical axis. You're looking for the lowest point and the highest point, the minimum and the maximum. So again, on this graph, our lowest point ends up being this endpoint we have right here. So this is our lowest point, and then the highest point happens to be that endpoint that we have on the other side. So vertically, the possible y values are going to be anything as low as -3 or as high as 4. And the y values can be anywhere in between that because this is continuous. So I would start with my minimum y value, which is -3. So -3 is less than or equal to the y, which is less than or equal to the maximum value, which is 4. So this is the lowest point on my graph, -3. This is the highest point on my graph at y equals 4. So my y's can be anything in between that. And then if I were to write this in the interval notation, again, because those are both included, I would do my bracket, put the minimum value, which I already found was -3, the maximum value, which is 4. So that interval is anywhere between or along -3 to 4. All right, number 5, which is the easiest one because number 5 is not a continuous graph. Number 5 is discrete. I'm going to put a little extra little note here. This is a discrete graph. There's no data from here to here or here to here or here to here. So the only values that exist are the x and y values of the exact points that are plotted. So when you have discrete points like this, you're just going to list the x and y values. And this is me just trying to include extra little notes to hopefully help you. When you just have points, like you'll have like on number 1 of your homework, it's just a set of ordered pair. It's just order pairs. So those are only points. So all you do is list the x values for the domain and list the y values for the range. That's it. There's no intervals, no whatever. This isn't even possible when we don't have continuous data. And then really this inequality, it's really just set notation because it's just a set of values. Okay? If it's discrete, it's just a set of values. So with a set, we're going to use the curvy brackets. And once again, all we're going to do is list for the domain the x coordinate of these 4 points. So the x coordinate of this point is -4. Then I move to my next point. The x value of this point is -1. Sorry. The x value of this point is +1. And then the x value of my 4th point is 3. So that is my set of domain values. That's my set of x's. And then for my range, I'm just going to list the y values of those points. So starting with my lowest point. So my lowest point has a y value of -2. Then this point has a y value of -1. My 3rd point has a y value of 0. And then last but not least, that has a y value of 2. So if it is a set of just points or ordered pairs or a table or whatever, don't make it harder than it is. You're just listing the x's, listing the y's. That's when it's easy. Okay, last one, number 6. That's going to require you to like think hard for a second. Now we've got a parabola that's opening down. We have these arrows that are showing me that as it continues to open down, it's also stretching out. So it's getting wider and wider and wider and wider as it's stretching down. So when we're thinking about the domain and we're looking left and right horizontally, it's never ending. It's going to continue, as it's opening down, it's going to continue to stretch to the left and it's going to continue to stretch to the right. So for the domain, we're going to go ahead and just write that it's all real numbers. Some of you have already done this. Negative infinity is less than x, which is less than positive infinity. Technically, that's correct. Your x values go all the way from negative infinity to positive infinity, but you can just write that as all real numbers. So like technically this is right. X is between negative infinity and positive infinity, but this works too. Okay? All right, now your range is not all real numbers because the minimum value, well, yeah, it's going down forever, right? So we have no minimum value, but we do have a highest point. So the highest point of our graph is at that vertex, and that vertex has a y value of -1. So our range is going to be anything -1 or less. So it is all y values that are less than or equal to -1. All y values that are less than or equal to -1. And again, technically, if you wanted to write it like a compound and you did negative infinity is less than y, which is less than or equal to -1, technically that is correct too. We just don't need all that. You can just do y is anything less than or equal to -1. All right, so now moving this or writing this in interval notation, I should have done that first, but all real numbers, nice and easy because you're just going to use the parentheses. The minimum is the negative infinity. The maximum is positive infinity. And you've got parentheses for both because infinities are always excluded. And then your range, again, that minimum value of the range is negative infinity. So it's going to start the same with that negative infinity. And then the maximum range is -1, but that -1 is included. So that -1 should have a square bracket because you can have a y value of -1. So you do that square bracket. Okay? All right. Easy stuff. Intercepts, x and y intercepts. Where does your graph go through these axes, right? So this is easy. An x-intercept is the x-coordinate where the graph intersects the x-axis. So this always happens where y is equal to 0. So you can always find your x-intercept. It's wherever y is 0. So it's always x, 0, whatever that coordinate is. But this y coordinate is always 0. And then your y-intercept is where the graph crosses the y-axis, and this will always happen where x is equal to 0. So it's always the point 0, y, whatever that y coordinate is. So 2 examples here. All we need to do when we're estimating the intercepts is just look at the graph. Where does it intersect those axes? And then write down those ordered pairs. So number 7, again, we've got that cubic graph. So we see that it intersects the x-axis in 2 places, and it intersects the y-axis in 1 spot. So you're just labeling those points. So this first point is -2, 0. And then this x-intercept is 1, 0. And then the y-intercept we got here, this is the point 0, 2. And then the last one, number 8, we've got an exponential graph, looking at where that graph goes through the axes. So we've got an x-intercept right here and a y-intercept right there. So the x-intercept is -1, 0. And the coordinates of this y-intercept are 0, -1. Okay. Ta-da, we did it. Notes number 1 done.